Hey guys, I'm Lucas and welcome to K-News episode 44 about another SpaceX Falcon 9. This is launch number 6 for SpaceX this year and maybe the 5th landing of the booster stage. Although it's called full thrust, it is not yet driven on its maximum power and will be further increased in future missions. Using its Merlin-powered upper stage, Falcon can lift up to 22.8 tons to a low Earth orbit and 8.3 tons to a geosynchronous transfer orbit in its expandable configuration. This number drops down to 5.5 tons however when landing the booster, and since the payload this time will weigh a little over 4.6 tons, there should be plenty room for error again. The rocket will lift off from Cape Canaveral, Florida on June 15th at 2:29 PM UTC or 10:29 in the morning locally. As usual, it will turn eastwards and head in the direction of the drone ship, Of Course I Still Love You, which was positioned in the ocean a few days ahead of time. I used to call it a barge in the past since it is towed by other ships, but Elon Musk pointed out it has its own engines to keep its GPS position and is therefore a ship. A few minutes into the flight, Falcon 9 will separate from its almost empty bottom half and continue with its upper stage. The booster will meanwhile use its wings and tiny thrusters to turn around and aim for the drone ship. Now the payload consists of two similar communication satellites. Both are built by Boeing and are based on its famous 702 satellite platform. There are multiple variants with different propulsion systems, and the one used here uses electric ion drives, which makes the satellites relatively lightweight compared to others. One will be launched for the French-based satellite provider Eutelsat and is called Eutelsat 117 West B. The other is launched for the company Asia Broadcast Satellite and called ABS-2A. For some this might sound familiar because in episode 4 I covered the Falcon 9 launch with Eutelsat 115 West B and ABS-3A. However, back then the Falcon 9 had not enough launch capabilities to return the booster and was therefore not equipped with landing legs. In this episode I want to talk a little about the ion drive, which sounds as if it came straight out of Hollywood, but is in fact reality for a long time. The first engine was built almost 60 years ago and the technology proven to work. However, an ion engine needs a lot of energy to work, and providing it in space is way more difficult than on ground. For example, the thruster based on Boeing's system utilizes almost 5,000 watts of power and generates only 0.000165 kilonewtons of thrust. For comparison, in KSP we get 2 kilonewtons out of them, which is 12,000 times more and pretty insane but necessary gameplay wise. I think it would be very boring to watch the thruster fire for days, but is of course not an issue in reality. What the engine does is it takes an atom and strips an electron from it to turn it into a positively charged ion. This ion then rushes towards a high voltage positive electric field in the back of the engine, where it gets its electron back and shoots out of the nozzle. Would it not receive its electron back, it would turn around and provide no thrust at all. Since it does and is shot out into space, it provides a little amount of thrust. The engine's efficiency depends, like those of all rockets, on the speed the exhaust gas can achieve, which is incredibly high on ion thrusters. Boeing's engine reaches a specific impulse of 3,500 seconds, which is 10 times more efficient than Falcon's Merlin engine for example. However, as mentioned, the thrust is very low, so such engines can only be used in space if you have enough time to perform a burn. Speaking of it, as the upper stage releases its payload one by one, they will fall towards the highest point in space and perform the necessary burn to circularize their orbits with its ion engines only. While heavier satellites with chemical engines need weeks to achieve it, both Eutelsat 117 and ABS-2A will perform burns for around 6 months to slowly increase their periapsis to its final altitude. Once they have reached their geosynchronous positions, they will cover the ground with communication services. Eutelsat 117 West B will be located at 116.8 degrees west over the American continent and cover parts of the North but mostly Middle and South America. ABS-2A on the other hand will place itself at 75 degrees east over the Indian Ocean and cover big parts of Russia, South and East Asia, but also East Africa and the Middle East. Now back to Falcon's booster. Having re-entered back into the atmosphere, it will use its guidance system, as it does at launch, to follow a ballistic curve aiming at the GPS coordinates the drone ship should be located. If everything goes according to plan, the Falcon 9 booster will reignite some of its engines to make a radical but efficient suicide burn. One engine alone has enough thrust to shoot the booster back up again, so it has to time the burn very well for a smooth touchdown. In the end, a little shout out to my Patreon of May 2016. Thanks for the support. Okay, That was K-News episode 44 about Falcon 9, and I hope to see you next one if you like. Auf Wiedersehen and thank you for watching.